The volume of a cone is actually related to the volume of a cylinder, where we've got our cone, which is kind of, a triangular shape, and we've got this circular base and we have a height. And what I know is that if I take my volume of a cone with a radius and a height, and I multiply that value by 1/3, because we can notice that these are completely related. Pi r squared times height. That is my formula for the volume of a cylinder. So if I multiply that volume of a cylinder by 1/3, I get my volume of a cone with that radius and height. So I actually know, before I know anything more about cones, I know that if I had a cylinder that was this, that had this height and base, that its volume would be 3 times the volume of this cone, because 1/3 of the volume of that cylinder gives me the volume of the cone. So if I had 3 cones filled with water that had the same radius and height as a cylinder, those 3 cones, each filled with water, would fill up that cylinder. So that's kind of our background information about our cone. So if our cylinder's formula was easy to memorize because it was just the area of a circle times height, then our cone formula would be easy to memorize as well, because it's just our cylinder formula times 1/3. Or you could just think of it as our cylinder formula, so pi r squared times height divided by 3. It's the same exact thing, however you want to look at it. So let's look at an example. So my height is from the tip of my cone to the center of our circular base. It's not the length of one of our sides. Make sure it's from the tip of our cone to that center of our circular base. That is our height. I'll mark it up here. Is from here to here. And our radius is from the center of the circular base to the outside of our circle. So if I'm finding the volume of a cone and I am given the height and the radius, and I'm given everything I need in my formula is V equals 1/3 pi r squared times height. I know that my radius is 6, so I'm replacing r with 6. And my height is 9. And then I'm going to solve. I'm going to put this in terms of pi first, just to relate back to that cylinder problem we did. So if I'm putting it in terms of pi, then I'm only going to plug into my calculator that 1/3 and this 6 squared times 9. So we're going to do 1/3 times 6 squared times 9. And I'm going to get 108 pi. That's if we leave it in terms of pi. If I want it not in terms of pi, then I'm just going to multiply everything together. So 1/3 times pi times 6 squared times 9. And I get 300. I'm doing the approximate, the little squiggly equal sign, because it's not exact, because we're rounding. 339 100.3 centimeters cubed, which you'll notice if you type in 108 pi, which is our terms of pi, it has the same value, 339.2920066. So that is the volume of that cone. Next, let's look at a word problem. So we can find the volume of our cone. We knew that this was centimeters cubed because we're dealing with volume, and volume is cubed because area is squared. It's 3-dimension, right? So we've got a little 3 right there. Let's look at this word problem. So this word problem says a cone-shaped funnel can hold 314 cubic inches of water. If the height of the funnel is 12 inches, what is the radius of the funnel? I'm going to add into this, use 3.144 pi. So what I'm going to do first is I'm going to notice that it's saying a cone-shaped funnel. So I'm going to draw a cone. If you know what a funnel looks like, it's just an upside down cone. You don't have to draw it upside down because you're still just dealing with a cone, but just for the sake of the context, I'm going to draw it upside down. A cone-shaped funnel can hold 314 cubic inches of water. So now that I drew my shape, I'm going to go through and identify the information I know. So it can hold 314 cubic inches. Cubic is our 3, so that's volume. So the volume is 314 inches cubed of water. If the height of the funnel is 12, another piece of information we know that the height is 12 inches. What is the radius of the funnel? So that is what I am looking for. It's my unknown. So I know the height is 12 and I'm looking for the radius. This is a little bit more complicated than when we were solving the cylinder problem because we're going to have to work backwards and deal with a square root. So stay with me. Okay. I know the volume and the height. I need to know the radius. So first I'm going to write the volume formula. V equals 1/3 pi r squared times height. My next step is going to be to plug in the information that I know. So my volume, sorry that this is kind of mixed together. My volume is 314. So I'm replacing my V with 314. 1/3, we're using 3.14 for pi. We do not know r, and then we know that the height is 12. So I've plugged in for everything that I know and then left our variable for r since I do not know that variable. Now I'm going to simplify both sides so that I can solve for r. What I can do first is just bring down my 314 because that can't be simplified anymore. I can multiply 1/3 times 3.14 times 12 because those are all being multiplied by that r squared. So I can just go ahead and do that now. So 1/3 times 3.14 times 12, and I'm getting 12.3 2.56 times r squared. If we're thinking about reverse PEMDAS, so the reverse of the orders of operations, we know that, so reverse PEMDAS, and this we go into more detail in my video on solving single variable equations, so SADMEP. There's no addition or subtraction to be done. There is multiplication or division because the r squared is being multiplied by 12.56. So I'm going to divide both sides by 12.56 because that has to happen before we can look at the exponent because that's toward the end. So I'm going to do 314 divided by 12.56 and I get 25. Wish I had more space. 25 equals r squared. Now that I've done the multiplication and division, I'm left with just r squared. So I can take the square root of both sides to get rid of the squared because that is the inverse operation. So the square root of 25 is 5. So our radius then is 5. And we are talking about inches. So I'm going to say r equals 5 inches. And you can always go back and plug into the formula to make sure you did it right. So if I know the radius is 5, then I should be able to plug in to my volume formula. So 1/3 pi, we're using 3.14, times our radius, which is 5 squared, times our height, which is 12, and I should get our volume, which is 314. Lastly, we have our volume of a sphere. So the volume of a sphere is going to be similar to our cone and our cylinder, but hopefully a little bit easier because we're just going to really be plugging into these formulas. The only difference is you'll sometimes be asked about a hemisphere, and if they ask about that, that's just half of a sphere. So you would just find the volume of the sphere and divide it by 2, which is the same thing as multiplying by 1/2. So we could also just say that this is our volume of a sphere divided by 2. The biggest difference with our spheres is that we no longer have a height. So instead of multiplying by height at the end, we're just multiplying by radius again. So it's 4/3 pi times radius times radius times radius, which is the same thing as 4/3 pi r cubed. So let's just look at an example. So this says find the volume of the sphere. It gives me my radius, which is 4. That's all I need to know. I have my formula, which is volume equals 4/3 pi r cubed. They gave me my radius is 4. So volume is going to be 4/3 pi. I'm going to plug in 4 for my radius cubed. So this is going to be in my calculator as 4/3 pi, and I can use the actual pi symbol, times r cubed. And in order to do cubed, you're going to use this little up and then put the 3. So the volume of this sphere with a radius of 4 is 268 about. I'm going to do my little about. And they did not give me any units. So I can say units cubed, or I can just have 268. So the hemisphere with a radius of 7 inches has a volume of 718.4 inches cubed.